what we're going to do now is we're going to talk a little bit about basic automotive systems. And I want to go over with you real quick engine configuration. So this is an engine block. For example, right here, back in the day, this would have been made out of cast iron. Today, maybe aluminum. However, this is a 4-cylinder inline. There are 6-cylinder inlines. 4-cylinder opposed, that is actually more of a Subaru Boxster engine. And then we also have the V, there's a V6, a V8, but I want you to understand that these cylinders right here, the number of cylinders in the engine configuration is how these engines are designed. They can also put them in there longitudinally or transversely. Longitudinally would be like a rear-wheel drive vehicle, like a big pickup truck, where the engine's in there long ways, or on these front-wheel drive cars, the engine is a transverse where it's actually in there, the engine's in there sideways. So that's our engine configuration. Now what we're going to talk a little bit about is the internal combustion engine. And this is when I saw this back in tech school at an early day, I was just absolutely amazed with how this works. But basically what we're going to do is I'm going to show you right here is this is a crankshaft. This is actually going to turn, and it's going to turn the oscillating motion into an up and down motion. So we have our piston and then our connecting rod. As this crankshaft goes around, the piston is going to come up. Our intake valve is going to open, and we're going to actually import or put in there air and fuel. And then as the piston comes down, it's going to suck in air and fuel. Then the piston's going to, as the crankshaft turns, the piston's going to come back up, and we're actually going to compress that air and fuel. And what we've done is we've made a little bitty bomb, and then as the piston reaches top dead center, we're going to light it on fire with a spark plug. This could be a minor explosion. It has nowhere to go, and that's going to push this piston down, and that's what gives us our power. And then as the crankshaft comes around again, the piston's going to come back up, our exhaust valve is going to open, and the exhaust goes out the door that way, out the engine that way. So that is our internal combustion engine 4-stroke cycle. And then if we combine that with the previous slide, you'll see that through those engine configurations, let's say for example, that inline 4-cylinder, these are all happening at different times. It's very synchronized, and that's how an engine runs and we get our power. Now, when we do this whole process, it does create a lot of heat, and we need to get the heat out of the system, out of the engine. So what we're going to do is, and just want a basic idea of how a cooling system works, but we're actually going to take this radiator right here, and we're going to put a fan on it, and we're going to take our hot antifreeze, which is inside the engine. It's going to come from our thermostat, and it's actually going to come in the top of the radiator, and this antifreeze is going to get spread out through this radiator, and the fan's going to cool it down. Then it's going to come out the lower hose, get sucked in by the water pump, and the cooler antifreeze is now going to go right back into the engine. And what we're doing is we're just constantly cycling over the antifreeze. It's going to be hot antifreeze in the top, comes out cooler, goes back in the hot engine, gets heated up again, goes back in that radiator to get cooled down. So this is a constant cycle going over and over again. Now, if you've ever wondered why it takes forever for your car to get heat in the morning on a cold day, well, we also have a little radiator inside our dashboard. It's called the heater core. And this heater core actually has 2 hoses that go to it. And once the engine gets warmed up, we start running that warm or hot antifreeze through our heater core, and then we blow a blower through that, and that's how we get our heat. So if you ever want to, get it when you're driving in the morning, you start your car up. And once you see your temperature gauge start to move, you'll start to realize that's when you start getting heat. But once again, we got to get the engine warmed up and our antifreeze warmed up so that we actually can use our heater core and heat in the vehicle. Now we're going to talk a little bit about the starting and charging system. And what this does is, you guys all know there's a battery underneath here, underneath our hood. So what we do is the engine, we're going to have it. Well, we just need to be turned over and get moving, and that's what's going to happen. The battery is going to operate the starter motor, and the starter motor is going to get the engine turning. Then once our spark plug fires, we get our power stroke, and then the engine starts. Once the engine starts, this starter has a little drive that will kick back out of the way, and then our alternator will take over. Our alternator is being turned by the alternator belt. And once the engine is up and running, this alternator is actually going to charge the battery back up as well as operate all the electronics and electrical stuff on the vehicle. So when we get a car in here at the shop, for example, and it's a no start, we always try to ask the customer on the phone, can you hear the engine cranking? Because if the answer is yes, if we turn the key and we hear crank, 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 but the engine's not starting, we now know that we're not getting either fuel, spark, or in some cases actually compression. So we will test for that, but if the customer comes in and says, no, I just hear a click, 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 well, most likely that's that starter just clicking against the flywheel and it's not going to start. So that's when we go into the starting and charging system test, and we're going to test the battery, starter, and the alternator and make sure that's all in good working order.